Hello everyone, welcome to SMT Call. Today we are going to solve another LeetCode problem, and today's problem name is increasing order search tree. So basically it's a binary tree related problem. So if you have not read the problem statement, you can stop the video and read the problem statement, then we can try to find out some solution for the same. So if you see that this question is being asked in several companies like Apple, Amazon and Facebook also, right? So basically if you can solve this problem, right, if you know that how to solve this kind of problem, then you will get a clear understanding of Inorder Traversal and even also the recursion and DFS also, right, in case of binary tree. So let's try to understand the problem statement. Okay, so what they are saying here, we will be given a root node, okay, and since it's a binary tree, it will have two child, left and right, 3 and 6. Okay, so what they are saying, we need to traverse the tree in Inorder Traversal, and then we need to make the leftmost node as the new root node, and we need to put all its child in the right side, so there will not be any left child. Okay, so you can see here our leftmost node is 1, and we put all the child or all the other nodes as a right child of 1. So it's a Inorder Traversal, right, means left, root, right. So we will come at 1 first, then we will go back to root, that is 2, that will be my left of 1, so 2. Then we don't have any right, so we will skip, we will go back to the root, now it is 3, so 3 will be left of 2. Similarly now we have right, so 4 will be the left of 3. Now again we will go back to 5, this is now again, this is left, root, right. Now we are at root, main root, right. So we will add 5, then we will similarly traverse the right side, 6, 7, 8 and 9. Okay, so this, in this way basically we need to form the new tree and return the new root node. Okay, so there are multiple ways to solve this problem, so let's see one approach first. Okay, so what we can do here, so this is our tree. Okay, so as I told you, right, we are going to use Inorder Traversal. So what is Inorder Traversal? It is always left, root, then right, correct. So how our pointer is currently at 5. Okay, we need to find out leftmost node, so we will go to the extreme left. Okay, 3, then 2, then 1. Okay, now again I can see there is no more left node, right, it is null, right. So I can see 1 is my extreme left node. So I will store, basically I will use some extra data structure in list, or you can say array, and I will store this value. So this is my extreme left node, right. So I will put 1. Now I will do Inorder Traversal, right. I will go back to 2, correct. So this is root, left, root, right. I will put 2 in our list. Now we will try to find out the right side. So there is nothing in the right side. Okay, so if it is null, then we are not going to insert anything now. So this portion of tree is done, right. Now again from right we will go back to 2. Now again we will go back to root of 2, that is 3. I will put 3 in our list. Then again I will try to figure out the right side. Again I will come at 4 and I will insert 4 because 4 don't have any left or right. Then again we will go back to 3, correct. Now again we will go back to the actual root, that is 5, and we will insert 5. Similarly we will go back to 6, like this. Okay, so basically using this way we are going to create a list of integer. Then using this list we can easily create this kind of tree, right. We can create a tree where we will only have the right node, right. So let's quickly see the code for this. Okay, so as I told you, we are going to use extra space, that is list, and we are going to store all the integer value or node value. Okay, let us name it as values, and we can use linked list implementation. Here I am using Java. Okay, so now what I will do, now I need to do the traversal, right. Okay, so for that, so it will be a recursive call, right. So I am going to create a separate helper function, and the task of the helper function will be updating the list with the node values while traversing in Inorder from. Okay, so let us name it as Inorder DFS, something like this. Okay, and we are going to pass two things here. So we are going to pass the node, initial root node, and we need to pass the list where we need to add the values. Okay, so it should be integer and it should be like a values, something like this. So what will be the stop case, or what will be the stop condition of this recursion, or base condition or exit condition? So here our exit condition will be 1. Whenever I will see my root is null, then we don't need to traverse that path basically, right. So we will add root is equals to null. Okay, So if it is there, then we can just stop the execution. So since it's a void, I need to just write return in Java. Okay. So now I am at 5, right? I need to find the leftmost node. So how we can do? We can call this function recursively with the left node or left child like this. So we can write like this in order dfs, and we will pass root dot left, and we will pass our values also. So we don't need to add values till now, right? We need to find the leftmost node, right? Now if we call this function, right, it will go to 3, then 2, then 1, then again it will go to the left, that is null, right? That means 1 is the leftmost node, right? Now we can add the value. We will do that now. Okay, so it will be values dot add, and we need to just add the root dot val. Now we added 1 in our list. Now I need to find out the right side. So there is nothing in the right, right? Okay, now I will go back to 2, that is root left, root right. So we will add 1 here, so 2 here. Okay, now once I reach to 2, and now I need to explore the right side. Okay, so I will call now same dfs function with the right side, because left, root, right. Okay, so it should be values. Fine. Now this function will basically create a list of this value like this 1 2 3 4 5 6 7 8 9. Now just I need to traverse the list, and I need to build the tree. So let's do that. So we need to return a new node, right? A new root node. So we will take a new root, and it should be, we can use some dummy value because this is like a dummy node. Okay, new tree node, we can take a -1. Now I need to traverse, right? And so while building the tree, I need another pointer, right, that to keep the current root. So we will take tree node cur root, and we will just copy the value because I need to temporarily save the actual root node value also, right? That is new road. Now we need to just run a for loop. So we can be like integer value, then values, then we can just form the value. How? So let us name it properly. It should be current root, and what we will do, I need to always append in the left side, right? So current root dot right, sorry, right side. Okay, right new tree node, then I need to just pass the value. So it will create a basically, now I am at 1, I will create a node 1, and I will add that in a right. Now I need to add in the next right, right? So I need to change the root, current root, right? Now my current root will be current root will be current root dot right. So now I am done with 1, I will come to 2, like this it will keep going, right? And once I am done, so this was the dummy node, right? New root of the dummy node -1. We don't need to return that. What I will do, I will just return new root dot right, because that is the correct root, right? Return new root dot right. So this will basically solve our problem. Let's try to run the code and see. Okay, so I think it's giving some error. Let me quickly fix this. So there is extra dot. Now let's try it once again. Okay, it's still throwing some error. Am I missing anything? Okay. So it should be current node new root dot right, and we are adding the root dot val also. Okay, so let's run this once again. Output should be new root integer dot values. So what is the problem here? Let's identify it quickly. Okay, so we are not calling this in order here, right? We need to call this in order here also, because we are not calling this function, right? In order dfs, and we need to call it with the root, and it should be obviously values. Okay, that's correct. Okay, so yeah, so I think this will now run. Let's try to do this now. You can see our solution is accepted, right? So what is the overall time and space complexity of this approach? So if you see properly, right, we were traversing all the nodes only once. So it's not like we are traversing a node repeatedly, right, since it's an in-order traversal, right? So we can say our time complexity is order of n. And what about the space complexity? Again, we are using extra list to store all the nodes, right? So it will be like again order of n. So both time and space complexity will be order of n. Okay, so that's pretty much for this video. If you like this video, please give it a thumbs up, and we will try to make another solution with another video. Okay, thanks for watching.